Next is your electrical resistivity method. So, basically electrical resistivity method means the material depends upon particularly type of electrical current it passed and how much is your resistance of this soil. From there you can find it out the change in strata. If I write type of soil, then resistivity, ohm meter, then your sound rock, weathered rock, gravel, sand, clay sand, saturated silt, it is greater than for sound rock 5000 ohm meter, weathered rock between 1500 to 2500 ohm meter, gravel is 1500 to 4500 meter, then ohm meter, sand is 500 to 1500 ohm meter, clay sand is 200 to 500, saturated clay 2 to 100. Now, there are two types of electrical resistivity method. One is your electrical profiling method, other is electrical sounding method. Now, in case of electrical profiling method, what happened, if this is the ground surface, now these are current electrodes, these are your electrodes and this is equal distance, say A and A, then outer will be connected with this meters, four electrodes driven in this method, electrical profile method, 4 electrodes driven, 4 electrodes driven inside the ground surface. Outer electrodes are known as these two outer electrodes, this is 1 and this is 2, 1 2 outer electrode, they are known as current electrodes, and inner 2 electrodes, this is 3 and 4, inner 2 electrodes 3 and 4 known as potential electrodes. So, mean resistance of this soil you can get it by applying DC current, by applying your DC current to the outer two electrodes. Then what is the voltage drop between two electrodes, inside electrodes measured. So, the mean resistivity rho you can measure by means of 2 pi A V by I is equal to current supplied, A is equal to spacing of electrode, V is equal to voltage drop. So, it can go, that means how much depth of penetration it can go. The depth of penetration is equal to equal to your spacing of electrodes. That means depth of penetration is equal to spacing between these electrodes. It is used to locate sand and gravel deposits. Now, electrical resistivity method means by drop of voltage, that means the method 1, electrical profile method. In the ground there are 4 electrodes installed or penetrate inside the ground, 4 electrodes. Out of 4 electrodes, outer 2 electrodes as worked as a current electrodes, that means apply by means of DC current has been applied both 1 and 2 electrodes, and how much voltage drop in 3 and 4 it has been measured, voltage drop in 3 and 4 or potential drop. From there electrical resistivity of the soil can be measured 2 pi A V by I is equal to current supplied, how much current supplied 1 and 2, and A is your spacing of electrodes, that is your A. V is equal to voltage drop, you can measure from here voltage drop, you can measure here how much current supplied, voltage drop in between these 3 and 4. Based on that you can find it out resistivity. Once you get the resistivity, what is the value of resistivity you look at, then you can say how much is your, means what is that soil, is it a sand, it is a rock, is it a gravel, or it is maybe clay or maybe saturated silt. The limitation is, that means the spacing of the electrodes, what is the spacing you are going to take up to that depth, that means suppose the spacing is A up to that depth, that means A, this particularly this voltage drop you can measure, beyond that you cannot measure, and used to locate sand and gravel deposits. Now, come to second part, that is your electrical sounding method. The limitation for this electrical profile method is you can go up to depth that is equal to spacing of these electrodes, you cannot go beyond that depth or you cannot measure electrical resistivity beyond that depth. Now, part B, that is your electrical sounding method. In electrical sounding method, look, second is your electrical sounding method. In this method there is a fixed location, this location has been fixed, not like electric profile method where you can vary. This location is fixed. With respect to this location, suppose case 1, this one varying A1, 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 this is varying. That means case 2 you can vary A2, case 3 you can vary A3. With this, with respect to fixed location, you can vary the spacing of the electrodes. These are A1, A2 or A3, these are all spacing of electrodes, spacing between the electrodes. You can vary the spacing between the electrodes so that you can reach up to the depth of exploration. Suppose this is my range, this is the range where the depth of exploration has to taken up to 10 meter from the ground surface, 0 to 10 meter, 0 to 10 meter depth of exploration has to be carried out. Suppose in 0 meter to 10 meter you are going to carrying out subsoil exploration. So, let us say every 2 meter interval. For 2 meter interval, then you set from the fixed location. So, A1 should be 2 meter. Then similarly, next 4 meter, A2 should be 4 meter, because in electrical resistivity, the resistance you can measure up to a distance that is equal to spacing between these electrodes. So, A1 is 2 meter, second case A2 is equal to 4 meter. Similarly, third case if you want to measure electrical resistivity or maybe ground response subsoil exploration at 10 meter depth by means of electrical resistivity, in that case the spacing should be 10 meter, so that exploration you can do it below 10 meter up to the ground surface. Now, there are limitations also in these methods. Means particularly if there is a wet soil or irregular soil profile, you may not get the electrical resistivity, whatever you are getting, you may not get accurate data. So, despite this, of this limitation, sometimes electrical resistivity has been used many places also to find it out resistance of the soil. Based on the resistance of the soil, you can say that this is either sand, gravel or clay sand or saturated silt. Next is your dilatometer test. Means dilatometer test has been developed by Marchetti. It is basically in situ penetration as well as expansion test. It is simple and easy to operate. So, best suited for sand, silt, clay and organic soils. It has not been used for hard rock. Now, what you are supposed to get from this test? Coefficient of lateral earth pressure, this coefficient of in situ conditions. I mean in situ conditions, coefficient of lateral earth pressure K0, then over consolidation ratio, coefficient of consolidation CH, undrained shear strength Cu and coefficient of permeability Kh, unit weight of soil as well as pore water pressure. Now, it has been initially introduced by Marchetti in 1975, then modified by Robertson. It is a standard flat dilatometer, and if you look at this part, you can say, if you look at here the layout of this DMT, it consists of a blade. This part is your blade, this is your blade. Now, come back to this instrumentation, it consists of blade with a member. This is the blade generally with a member, then control unit, this is your control unit outside, and pneumatic electric cable, this is your pneumatic electric cable, then pressure source, electric ground cable. Now, how it works? Now, this if you come back to earlier PPT, how it works? It is a blade. If you look at here, this entire part is a, here it is a blade. With this blade action, how it has been done in the field, it is connected by means of a stainless steel member. Inside there is a spring and plexiglass cylinder also there, and plastic insulating sheets are also there. By means of gas, once it enters, so it will try to expand outside. The moment it expand outside, so soil will give resistance. So this resistance or the sigma 3 you can get it, how much this spring will be compressed, from there you can get it. And there are two parameters required to find it out. One is your how much external pressure applied to the membrane, then is your internal pressure which in free air lifts the membrane center 1.1 mm from its sitting positions. Generally delta A and delta B 5 to 30 kPa, delta A, and delta B 5 to 80 kPa has been taken. As I said earlier, the procedure is like this. The moment by means of gas, it will try to expand. Once it expand, what will happen? Here the soil is there. With this soil resistance, then the spring will be either expand or maybe contract. Based on the spring resistance, you can find it out sigma 3. So these are the all dilatometer test reduction formula for different P0 and P1, how to find it out: KD horizontal stress index, ED dilatometer modulus, K0 coefficient of earth pressure in situ. This is our requirement. Then over consolidation ratio also, this is also our requirement. Then this is your coefficient of permeability, unit weight of the soil required. Also the in free draining soils equilibrium pore pressure you can measure it. It has great advantage, many parameters you can get it, like I say you can find it out K value, then also you can find it out permeability, coefficient of lateral earth pressure K0, over consolidation ratio, coefficient of consolidation, ondent shear strength, permeability, unit weight of soil gamma, equilibrium pore pressure U0. Many things you can find it out from this test. It has advantage also as compared to other in situ tests. Now that is another, it is plotted with dilatometer index ED versus the material index ID, charts for estimating type and weight of the soil. If you see this, there are range A, B, C and D types of soils. From this range you can find it out. If you know the ED and material index, you can find it out what kind of soil, where is the range, you can easily find it out. Application to engineering problem: settlement of shallow foundation, you can also get settlement in sand, settlement in clay, then detecting slip surface in slopes, and also as well as you are measuring pore water pressure, you can also determine liquefaction as well. It is a quick estimate, it is a quick test, sometimes we say it is a quick test. DMT generally dilatometer test expressed in terms of three parameters, that is KD, in situ K0 and ED, used in clay, silt, sand, even also soft rock. However, it cannot be used for hard soil through which blade cannot penetrate, because you have to penetrate that blade. For hard soil it is very difficult to penetrate that blade. Now other test, as I said also I have explained earlier, if you remember well, that is your standard penetration test. By blackboard I draw this diagram, you can see this schematic diagram of the standard penetration test. If you look at here, now this is your hammer, then it drops height of 75, this is 65, in Indian condition it is used, as for ASTM it is 63.5, and height of hull is 76, but some other standard it is sometimes 75, sometimes it is 65 also. So, this is schematically it has been shown. This is your tripod. By means of pulley manually you can do it, pull it, so that you can raise certain height and it can be dropped at a height of say 75 centimeter. So, penetration obtained for last 30 centimeter is recorded as N value. So, this is your sampler, split spoon sampler details I have already explained. Now, if you see this, how many corrections required, what are the factors affecting N value in field, what type of hammer used, it depends upon the hammer type, also how the hammer release, it is manually or maybe mechanically operated, what is the sample tube used, length and type of drill rods, frequency of hammer bows, then borehole diameter, drill pit type and configurations, then frequency of hammer blows, sorry this is wrong, this will be blows. Corrections for soil conditions, as I said earlier, there are two corrections, overburden correction as well as dilatancy correction. Then correction for hammer, it is N60, if I say it will be NF, NF is your SPT after corrected, then NF is your SPT in the field not after corrected, N1, N2, N3, N4, N5 and N6. N1 is your energy correction factor, N2 is your rod length correction factor, N3 is your linear correction factor, N4 is your borehole diameter correction factor, N5 is your anvil correction factor, N6 is your blow count frequency correction factor. These are the required corrections you have to apply. Once you take N60, then it is your field value of penetration blow. With these corrections it required, means you have to apply. Then correlations, it has been explained also earlier. For sand, normally consolidated sand, you can find it out ES soil 500 into N plus 15. For sand, silt and clay, you can find it out ES is equal to 300 into N plus 6. These are the design charts after the spec ETL 1974 with respect to N and D by B ratio. From there you can find it out your bearing capacity. That means suppose say D by B is equal to 1. So, with this 0.5 depth is bearing pressure, you can find it out. Suppose N you are getting, suppose how much is your N, based on the N you can find it out what is your bearing pressure. These are the chart. Indirectly you can get bearing capacity of foundation based on also N value. Now, another important part I have not said, can I measure unit skin friction from SPT? Yes. Now, it is the latest development, means unit friction can be obtained by rotating SPT split barrel sampler, split spoon sampler here. This is your, you can say this is your sampler. By rotating, once you penetrate, once after taking the SPT, suppose at this height or this distance you are measuring the value of N, after measuring the SPT standard, after conducting the standard penetration test, then you can rotate the SPT sampler. This is your SPT sampler driven inside, so that you can get skin friction, means how much torque it can take by means of rotation, how much torque it can take. Based on that you can find it out skin friction Fs is equal to 2T phi L d square. T is your measured torque you can measure torque outside, you can find it out how much torque it can take. D is your outside diameter of split barrel sampler, L is equal to length of penetration. Now, whether this is possible or not, unit skin friction can be carried out or not from standard penetration test. So, basically it has been there are case studies, means tests were performed at 12 sites across in US, United States, to evaluate the skin friction measurement obtained with SPT and T. Based on that skin friction measurement, a simple linear correlation between the measured skin friction and the SPT is provided. So, this has been given by Swan et al. 1998. They proposed correlation between the measured FS from SPT T and SPT N. Limitations also I said, SPT is subjected to many errors which affect their design. There are many errors. SPT value is not appropriate for determining allowable bearing pressure of fine grained cohesive soil. Limitation 2. Then reliability of the test for obtaining different dynamic properties of soil like seismic velocity must be checked. How reliable? You should check this data. Testing should be accomplished in several boring in varying soil. Before arriving value of N, you have to do lot of tests in several boring, and energy measurement, check the energy measurement, because in these energy measurements corrections also required. Despite several limitations, SPT is standard penetration test is most popular to get N. From there you can get phi, from there indirectly you can get also your bearing capacity of footing. Now, if you look at the next part, as I said earlier, plate load test, the figure, now I am showing this figure. If you look at here, I have already explained in this lecture classes also. Look at the pit, here it is the pit has been made. Then once the pit has been made, plate is placed here, this is your plate. Then with this plate a reaction frame, you see it is a reaction beam, reaction frame has been placed. Over the reaction beam a load platform has been made and also load applied. What will happen? By means of hydraulic jack, whatever I apply the pressure to the hydraulic jack, it will try to uplift the reaction beam. If proper loading platform has been made with loading systems, so it will not allow to push this reaction frame from outside, rather each action has equal and opposite reaction. From there what will happen? Once it apply this reaction here, it will take it, then it will plate will settle with your opposite action. Then at this particularly in this plate, as I said, two dial gauges has been provided or placed at the opposite of this plate, at the opposite of this plate. Here dial gauge 1, here dial gauge 2. So this is just I want to show it how diagrammatically, how in figure it is clear, so that you can visualize what is this plate load test mean. Now look at this figure. In real field there is a loading platform, a pit has been made from here to here, pit has been made, and this is the loading platform, and this plate load test has been carried out. The photograph I put it directly. Then this has been also discussed, what type of curve you are going to get for cohesive soil, for medium soil figure, for this dense soil, what type of you are going to get. If I plot, now come back to here, if you look the load versus settlement diagram or this, if this kind of curves are there, where you can get failure load easily. In that case, if I draw in log plot, definitely there will be a yield stress, you will get it directly. The curve in log plot, it will go in this way. You will get one yield point or maybe a point where the failure load is observed, we can get directly. So, sometimes it is said in this approximate yield stress, beyond this it is called elastic settlement. From here to here it is called elastic settlement. Beyond means before this yield stress it is elastic settlement, beyond yield stress this is called plastic yield settlement. This is called plastic yield settlement. Now, as I said, using plate load test you can find it out settlement of soil, or also you can get influence factor. Another one is a load settlement curve used to evaluate modulus of subgrade reactions, means K value you can find it out P by Y. From this you can find it out modulus of subgrade reaction. What are the limitations? This part I have not discussed. What are the limitations? In plate load test, the limitation is depth of soil affected by plate load much lesser than depth of soil affected by foundation. If I say this is my plate, so depth only affected by very small area, and this is my footing, that means it is affected by much larger area. Then results of the test indicate only about immediate settlement, only about immediate settlement. Relation between bearing capacity and width of plate is linear, which is not the actual case in case of foundation where it is non-linear. Effect of size of plate on bearing capacity of soil in cohesionless soil, this is called scale effect. Then effect of capillarity on the result of plate load test. These are all limitations. That is another test, it is called screw plate load test. This test was primarily developed to overcome the difficulties associated with this plate load test. The test is suitable for loose to medium dense soil. The instrument consists of single flight earth auger which is inserted to the requisite depth, and the loading is done through hydraulic jack, you can see it here. The results of this test is similar to that of plate load test. The test gives economical determination of settlement with depth. Look at here, screwed plate, a plate it is screwed, it is put in a shaft, so it has been pushed. Then the plate load test has been done by means of the procedure, earlier procedure for regular plate load test, same procedure has been applied. Here the settlement observed is more accurate. This plate is specifically designed to measure subgrade deflection independent of total plate deflection. Look the difference. It is specially designed to measure the subgrade deflection which is independent of total plate deflection. Then next question is, with this plate load test, will it be possible to conduct a cyclic plate load test? Yes. Generally cyclic plate load test is required to simulate traffic condition by repeated loading. Load are applied in cyclic manner, loading and reloading, that means first set of load whatever you apply in plate load test, in next step instead of applying second increment of load you can reload it. Then again you apply your, after reloading you apply your second increment of load. It establishes the progression of accumulated deflection due to both elastic and permanent deflection. The load cycle curves gives the bearing value of any particular deflection, and determination of deflection of modulus and bearing value for particular deflection, you can find it out. Why this cyclic plate load test is required, if somebody will ask, it basically to simulate the traffic condition by repeated loading, to simulate the traffic conditions by repeated loading. So, second step is loads are applied in cyclic manner. That means, suppose in plate load test initially you apply first load is 10 kg per cm square, second is your 20, third is your 30, then 40. If you apply like this 10, 20, 30, 40 kilonewton per centimeter square or kg per cm square, if you apply, what generally happen in general plate load test? First we apply 10, then you wait the rate of settlement, then again we increase the second increment 20, then you wait till the settlement become is equal to 0.01 mm per hour, then apply third, fourth increment like this. But in cyclic plate load test you first apply 10, wait till your settlement to become constant or less settlement occur, then after that you immediately unload the means 10 kilonewton you immediately take out. Once you take it out, the next step you apply 20 kilonewton, again unload it, then you proceed in this way.